There's a strange kind of poetry in watching something the world threw away become the very thing we build our future on. A tire, blackened and worn, cast aside after years of rolling through rain and heat and the weight of 10,000 miles. It sits in a yard somewhere, stacked with a million others, waiting. Most people see garbage. But if you've spent any time around production lines or construction sites, you know better. You see potential. You see raw material. You see the beginning of something that hasn't been built yet. It takes 4,000 years for a tire to break down on its own. 4,000. That's longer than most civilizations. And for decades, that made them one of the most stubborn problems we had. Too toxic to burn safely. Too durable to bury. Too heavy to ignore. They piled up in deserts, in abandoned lots, in places where no one wanted to look. But somewhere along the way, someone stopped seeing waste and started seeing structure. And that shift, that quiet change in perspective, turned a mountain of discarded rubber into one of the most valuable materials in modern road construction. Today, old tires aren't trash, they're treasure. Engineers call them black gold. And the roads we drive on, the ones that last longer and crack less and absorb the noise of 100,000 passing wheels, they're made, in part, from the very tires that used to roll across them. The journey starts in the places you'd expect: roadside garages, tire shops, scrap yards where the air smells like oil and old rubber. Every day, thousands of tires reach the end of what they were made to do. The tread is gone, the sidewalls are cracked, the rubber has lost its grip. They're done, but they're not finished, not yet. Collection trucks roll through on fixed routes, gathering them up, stacking them high on flatbeds. It's methodical, efficient, the kind of work that doesn't draw attention but keeps the system moving. And anyone who's worked logistics knows, it's not the flashy stuff that matters. It's the rhythm, the consistency, the understanding that every piece has to flow or the whole line stops. Those tires get delivered to recycling plants, and that's where the real work begins. But before you can turn rubber into road material, you have to deal with the steel. Every tire has a steel bead embedded inside it. That's what locks it onto the rim when you're doing 70 down the highway. It's strong, it's necessary, but in a recycling line, it's an obstacle. If you try to shred a tire without removing that steel first, you'll break blades, jam motors, and bring the whole operation to a halt. So the first step is extraction. Workers feed the tire into a bead removal machine, a hydraulic system that grips the steel ring and yanks it out with enough force to twist the rubber body like it's made of clay. It's violent, it's fast, and it works. Each heavy-duty truck tire gives up about 2 kilograms of high-quality carbon steel. That steel gets bundled, shipped off to a metallurgical plant, and starts its own second life. Meanwhile, the tire, now softer, more flexible, moves on. If you've ever worked around cutting equipment, you know that prep matters. Before the shredding starts, every tire goes through a high-pressure wash. Mud, oil, gravel, road grime, all of it gets blasted off. It seems like a small thing, but that wash protects the blades, extends the life of the machinery, and keeps the downstream process clean. It's one of those quiet decisions that separates a plant that runs smoothly from one that's always breaking down. Then comes the shredding. Whole tires are fed into high-torque cutters with alloy steel blades that rotate slowly, slicing the rubber into coarse chunks. Low speed means low heat, and low heat means the rubber doesn't soften or stick. It just cuts. Clean. Controlled. The pieces that come out are several inches across, still rough, still mixed with bits of steel fiber and textile, but starting to look less like tires and more like raw material. Next is secondary grinding. The chunks get smaller. The embedded steel gets fractured and separated. Magnetic systems pull the metal out of the flow, recovering it for recycling. What's left is crumb rubber, tiny particles, tightly controlled in size, ready to be classified and sent forward. At this stage, the tire has lost its shape entirely. It's been broken down into its elements, and in that breakdown, there's a kind of clarity. What was once a single object is now a collection of components, each one waiting to be reassembled into something new. The screening system sorts everything by size. Particles that are too large get sent back to the grinder. Particles that meet the spec especially the ones between 0.5 and 2 millimeters, get set aside. That's the sweet spot. That's the size that works best for rubberized asphalt. And that's where the real transformation begins. You've probably seen material come off a line still holding moisture, still carrying dust. It happens. But when you're about to mix rubber with hot bitumen, that moisture is a problem. It interferes with bonding. It weakens the final product. So, before the crumb rubber can be blended, it has to be dried and heated. The granules are fed into a rotating drum, a long steel cylinder, tilted slightly, turning constantly. Hot air flows through it, pulling the moisture out, warming the surface of each particle, making it chemically active. It's a gentle process, controlled. The goal isn't to cook the rubber, it's to prepare it, to make it ready to absorb, to bond, to become part of something larger. Anyone who's spent time in a plant understands the importance of temperature control. Too hot, and you damage the material. Too cool, and the reaction doesn't happen. So the system monitors everything: airflow, drum rotation, particle temperature. Some facilities use indirect heating to keep the rubber away from direct. Flame, preserving the polymer structure inside each tiny piece. It's precision work, and it matters. Once the rubber is dry and warm, it meets the bitumen. The bitumen has been heated separately, brought to a stable liquid state, usually somewhere between 320 and 375 degrees Fahrenheit. The crumb rubber is added in controlled doses, 10 to 20% of the total mass, depending on the formulation. And then the mixing begins. Inside the blending chamber, heat-resistant paddles spin, creating a vortex that forces the rubber and bitumen into contact. This isn't just stirring, it's interaction. The rubber particles swell as they absorb lighter oils from the bitumen. The mixture thickens, the elasticity increases, and over 30 to 60 minutes, something remarkable happens. The two materials stop being separate. They become one. A rubberized binder that's stronger, more flexible, more resistant to cracking than either component alone. Those who've been around factories long enough recognize this moment. It's the moment when waste becomes value, when something discarded finds purpose again. And it happens not through force, but through patience, through heat, through time. The blended asphalt is loaded into preheated dump trucks and transported to the job site. The mixture is still hot, between 270 and 300 degrees, so it flows, spreads, settles. A paver distributes it evenly across the lane. Steel rollers compact it while it's still warm. Pneumatic rollers seal the surface. And within hours, the road is ready. Smooth, solid. Built in part from tires that once rolled across pavement just like this. It's a closed loop, a system that feeds itself. And what makes it work isn't just the machinery or the chemistry. It's the understanding that materials don't have fixed identities. A tire isn't just a tire. Asphalt isn't just asphalt. Everything is part of a larger flow, moving from one form to another, finding new uses, new meanings, new life. Even after the rubberized asphalt has been laid, compacted, and driven on for years, the cycle continues. Eventually, that road will crack. It will age. It will need to be replaced. And when it does, the asphalt itself, rubber and all, gets milled up, collected, and sent back to a recycling plant. It becomes RAP, reclaimed asphalt pavement, and it starts the process again. Crushed, cleaned, heated, blended, reborn. There's something humbling about that. The idea that nothing is ever truly finished, that every end is also a beginning, that the roads we build today will become the roads we build tomorrow in a form we can't quite predict but can trust will emerge. If you want to keep exploring the hidden systems that shape the world we live in, the factories, the processes, the quiet transformations that happen behind the scenes, I hope you'll like this video and subscribe. Leave a comment if this story made you see old tires or roads or waste itself a little differently. Because in the end, value doesn't lie in what something looks like. It lies in how we choose to see it. And sometimes, the most valuable things are the ones the world has already thrown away.